Good afternoon. Today I am going to take a topic about oscillation. So when we heard the word oscillation, the first thing which will come into our mind is a simple pendulum, right? When we heard a word called oscillation, the first thing which will come into our mind is a simple pendulum. So simply we will define the process oscillation as it is a to and fro motion of a body. So when we heard the process of oscillation, or when we heard a word called oscillation, the first thing which will come into our mind is a simple pendulum. So if we consider a simple pendulum, what is the basic structure of a simple pendulum? A simple pendulum will have a point of suspension. From this point of suspension, there will be a string of length N. At the end of this string, there will be a bob of mass M. This is the basic structure of a simple pendulum. There will be a point of suspension. From this point of suspension, there will be a string of length L. At the end of the string, there will be a bob of mass M. So this is the basic structure of a simple pendulum. So suddenly, when we heard a process called oscillation, the first thing which will come into our mind is a simple pendulum. So simply we will define the process oscillation as it is the to and fro motion of a body. And what is the actual meaning or actual definition of process called oscillation? How we will define the process called oscillation in a complete way? In order for that, we are considering this basic structure of a simple pendulum. Here, there will be a point of suspension. From this point of suspension, there will be a string of length L. At the end of this string, there will be a bob of mass M. So the length of the pendulum is the distance between the point of suspension and the tip of the bob. This distance will give the length of the pendulum. So length of the pendulum is the distance between the point of suspension and the tip of this bob. That is the length of the pendulum. So now we are going to find out is how we can define the process called oscillation in the actual definition or in a complete way. For that, we are considering this simple pendulum. Initially, if we are not applying any external force on this bob of mass M, in order to oscillate this bob of mass M, we have to apply an external force on this bob of mass M. Then only we can oscillate this bob of mass M or this pendulum. Otherwise, the bob will remain in its state of rest. So our intention is to oscillate this bob of mass M or oscillate this pendulum. For that, externally we are applying a force on this bob of mass M. So initially, if we not apply any external force on this bob of mass M, the bob will remain in its state of rest and the bob will not oscillate. If we will not apply any external force on this bob of mass M, the bob will not oscillate and the bob will remain in its state of rest. So that position, the position where there is no external force acting on this bob of mass M, it is called the equilibrium position or mean position of the bob. Equilibrium position or mean position. Mean position. Equilibrium position or mean position. Or mean position. That is, equilibrium position or mean position is the position of this particular bob where there is no external forces are acting on this bob. If no any external forces are acting on this bob, the bob will not oscillate and the bob will remain in its state of rest, or it will continue the position of equilibrium position or mean position. So the equilibrium position or mean position of a bob is the position of a bob where there is no external forces are acting on this bob. Now what we are going to do is, externally by applying external force on this bob, we are applying a force on this bob and we are going to oscillate this bob. So in order to oscillate this bob of mass M, we have to apply external force on this bob. So by applying external force on this bob, this is the basic structure of a simple pendulum. This is the point of suspension. From this point of suspension, there will be a string of length L, and at the end of the string, there will be a bob of mass M. So, if you are not applying any external force on this bob of mass M, the bob will remain in its state of rest, and that particular position of the bob, where no external forces are acting on this bob, is called its equilibrium position or mean position of the bob. Equilibrium position or mean position. Now, what we are going to do is, we are going to oscillate this bob of mass M. So, in order to oscillate this bob of mass M, we have to apply external force on the bob. For any body, in order to accelerate a body, we have to apply external force. If it is any body, whatever the body, in order to accelerate that particular body, we have to apply external force. Like that, here also, in order to oscillate this bob of mass M, we have to apply external force on this bob of mass M. So by applying external force on this bob of mass M, we are taking this bob of mass M from its equilibrium position to another extreme position P. Extreme position P. So here O I am taking as the equilibrium position of the bob. And P I am taking as the extreme position of the bob. So by applying externally, we applied force on this bob of mass M, and we are taking this bob of mass M from the equilibrium position to the extreme position P. Now at the extreme position P, if we release the force with a displacement x, very important. From now, what we are going to do is, we are going to oscillate this bob of mass M. So in order to oscillate this bob of mass M, we have to apply external force on this bob of mass M. By applying force externally, we are taking this bob of mass M from the equilibrium position to extreme position P with displacement x. So here x is the displacement from the equilibrium position to the extreme position. Displacement we will always define, it is the shortest distance between the two positions, initial position and final position. Here O or the equilibrium position is the initial position, and P or the extreme position is the final position of the bob. So by applying external force, we are taking the bob from the equilibrium position to one extreme position P. Now from this extreme position P with a displacement x. Now from the extreme position P, if we release the force on the bob of mass M, the bob will reduce that much of displacement and will come back to the equilibrium position O. Again, from this equilibrium position O, the bob will go to another extreme Q with another displacement x. At this extreme position P, again, the value of the displacement of the bob will be maximum and the final velocity of the bob will become 0. At that point, the bob will reduce that much of displacement x and will come back to the equilibrium position or the mean position. Again, bob will go to another extreme P with a displacement x. At this extreme position P, the displacement of the bob will become maximum and the final velocity of the bob will become 0. And the bob will reduce that much of displacement and will come back to the equilibrium position O, which will complete one oscillation. Completes one oscillation. So this is the process of oscillation, and this process will continue for a particular interval of time, or this process will repeat. This process will repeat for a particular time interval. So what is oscillation? In this process, the O, by applying external force on this bob, the bob moved between these two extreme positions P and Q through a fixed point equilibrium position. So actually the oscillation, the complete definition of oscillation is, it is the to and fro motion of a body between two extremes through a fixed point in a particular interval of time, which repeats in a particular interval of time. So oscillation, we will define oscillation in a complete way as, it is the to and fro motion of a body between two extremes through a fixed point, and will repeat, and that process will repeat for a particular interval of time. This is the complete definition of oscillation. It is the to and fro motion of a body between two extremes through a fixed point. Here, in each oscillation, the bob went from P and Q from Q and P. The bob crossed the equilibrium position O. So, oscillation is the to and fro motion of a body between these two extremes through a fixed point. Here, fixed point is the equilibrium position, and that process will repeat for a particular interval of time. This is the actual definition of oscillation. Now, why we are calling this P and Q as the extreme positions? Why we are calling this P and Q as the extreme positions? Because here, by applying external force on this bob of mass m, the bob, we took this bob from the equilibrium position to the extreme position P with displacement x. At this extreme position P, the value of the displacement of the bob will be maximum, and the final velocity of the bob will become 0. At that point, the bob will come back to the equilibrium position by decreasing that much of displacement. So that's why we are calling this P and Q as the extreme positions, because at that positions, the displacement of that particular bob will be maximum. That's why we are calling these two positions as the extreme positions. In real life example, when we throw a body from the ground level to upward direction, the body will move to upward direction with displacement s. At a particular point, the displacement s, the value of the displacement of that particular body will be maximum. At that point, the final velocity of the body will become 0. So whenever the displacement is maximum, the value of the final velocity will be 0. At that time, the body will come back to the ground level. Likewise, here also, at this extreme position P, the body will attain its maximum displacement. That's why we are calling P and Q as the extreme positions. So at this extreme position P and Q, the displacement of the bob will be maximum. At that time, the value of the final velocity will be 0. If the final velocity of a body is 0, means the body is not moving further. Means that if the final velocity of a body is 0, means the body will not move further. So, in these two extreme positions, the value of the displacement of the bob will be maximum. When the displacement is maximum, at that point, the final velocity of that bob will be 0. At that time, the bob will not further and will come back to the equilibrium position. So, that's why we are calling P and Q as the extreme positions, because in these two positions, the displacement of the bob will be maximum. Displacements of the bob will be maximum. At that time, the final velocity of the bob will be 0 and the bob will come back to the equilibrium position. So, this is how we are defining the process of oscillation in a complete way. Now we are going to learn some important terms associated with this oscillation. First term is time period. What is time period? What is frequency? What is amplitude? Time period of oscillation. It is the time taken by the bob to complete one complete oscillation. One oscillation. It is the time taken by the bob to complete one oscillation. For that, we are considering a simple pendulum. This is the point of suspension. From this point of suspension, there will be a string of length L. At the end of this string, there will be a bob of mass. So this is the length of the pendulum. It is the distance between the point of suspension and the tip of the bob. Length of the pendulum, L. So here, this is the mean position where there is no external forces are acting on the bob. If no external forces are acting on the bob will remain in its state of rest, and that particular position of the bob is called the equilibrium position or the mean position of the bob. position or the mean position of the bob. Now what we are going to find out, what is the exact meaning of time period? It is the, simply we will say as it is the time taken by the bob to complete one oscillation. So now what we are going to do is, we are applying some external force on this bob. We are taking this bob from the equilibrium position to one extreme position P. So why we are calling P as the extreme position? Because at this extreme position P, the displacement of the bob will be maximum and the final velocity of the bob will become 0 with a displacement x. So at this extreme position P, the displacement of the bob will be maximum and the final velocity of the bob will become 0, and the bob will reduce that much of displacement and will come back to the equilibrium position. Again, from this equilibrium position with another x displacement, the bob will go to another extreme Q. Here also at this extreme position Q, the displacement of the bob will again become maximum and the final velocity will become 0. And the bob will reduces that much of displacement and will come back to the equilibrium position. Again from this equilibrium position, the bob will go to another extreme position P. At this extreme position, displacement of the bob will become maximum and the final velocity at this extreme position P, the bob will achieve its maximum displacement. At that time, the final velocity of the bob will become 0 and the bob will come back to the equilibrium position O, which completes one oscillation. So one oscillation, in order to complete one oscillation, initially bob should go to this extreme, then will come back to the equilibrium position O. Again we'll go to another extreme, we'll come back to equilibrium position O. Again we'll go to this extreme, we'll come back to equilibrium position O, which completes one oscillation. So time period is the time taken by this bob to complete this one oscillation. How much time this bob has taken in order to complete this one complete oscillation is called the time period. Time period we will always denote it in seconds. Next is frequency. Frequency we will denote it as mu. So the relationship between velocity and wavelength, V is equal to mu lambda. There will be velocity directly proportional to lambda, or velocity V is equal to mu lambda. Here mu will become the constant. So frequency will denote it as mu. Frequency is defined as, if you take a unit time, in a unit time, how much oscillation, number of oscillation the bob is covering in a unit time is called the frequency. In a unit time, number of oscillations the bob is covering in a unit time is called its frequency. Next is amplitude. Amplitude is the maximum displacement. So these are the important terms associated with the process called oscillation. So now we have learned what is the exact meaning of oscillation from an example. After that we learn what is time period, some important terms associated with the process called oscillation, time period, frequency and amplitude. Now we are going to learn that we will call the essence of a oscillation, we will call as simple harmonic motion. Why we are calling simple harmonic motion as the essence of oscillation? Always we will call simple harmonic motion as the essence of oscillation. Essence of process called oscillation. So now we are going to study why we are calling this simple harmonic motion as the essence of oscillation. Why we are calling like that? Is that true? Is that we are calling essence of oscillation as simple harmonic motion is true? Now we are going to check whether this statement is true. Can we call simple harmonic motion as the essence of oscillation? For that, going to our simple pendulum structure. So this is the point of suspension. From this point of suspension, there will be a string of length L. At the end portion, there will be a bob of mass M. There will be a bob of mass M. So this is the length of the pendulum. From the point of, it is the distance between the point of suspension and the bob of mass M. So this is the length of the pendulum. Now we are going to learn whether we can call simple harmonic motion as the essence of oscillation. For that, we are going to find out the first, there are three important properties for a simple harmonic motion. Now we are going to find out the three important properties of simple harmonic motion. First important property is the displacement and the corresponding acceleration of the bob. Both are directly proportional and both are in opposite direction. This is the first important property of simple harmonic motion. The displacement of the bob and the corresponding acceleration both are directly proportional but both are in opposite direction. This is the first important property of simple harmonic motion. Now we are going to check whether this first property is completely obeying by this process called oscillation. For that, we are going to the picture of simple pendulum. Length of the pendulum. Now we are going to find out whether the first property of simple harmonic motion is completely obeying this process called oscillation. For that we are going this. Here we are going to find out whether the first property of simple harmonic motion is completely obeying by this process called oscillation. Process called oscillation. For that, initially, if you are not applying any external force on this bob of mass M, the bob will be in its state of rest. If you are not applying any force on this bob of mass M, the bob will remain in its state of rest. And that particular position of the bob is called the equilibrium position or mean position of the bob. So equilibrium position or mean position is the position of the bob where there is no external forces are acting on this bob of mass M. Now, by applying external force on this bob of mass M, we are taking the bob from the equilibrium position O to the extreme position P. One extreme position P. At this extreme position, if with the displacement x, now we are taking the bob of mass M from the equilibrium position to extreme position P in a displacement x. At this extreme position P, if we release the force, extreme position P. At this extreme position P, the final displacement of the bob will be maximum and the final velocity of the bob will become 0. At that point, the bob will come back to the equilibrium position O by reducing that much of displacement x. Again, from this equilibrium position, the bob will go to another extreme Q. with another displacement x. At this extreme position q, the value of displacement will become maximum and the velocity will become 0. At that point, again the bob will come back. At that point, bob will come back to the equilibrium position O by reducing that much of displacement. Now, first property is that acceleration and the corresponding displacement of the bob both are in directly proportional, but both are opposite direction. Now we can check whether this property is true or not in case of process oscillation. In first case, we are taking the extreme position P very far away from this equilibrium position O. We are taking the extreme position P very far from the equilibrium position O. So if the extreme position P is very far from the equilibrium position O, the value of the displacement in this case will be very high, right? Value of the displacement will be very high. At that time, if we release the force from the extreme position P, the bob will accelerate with a very high, or the acceleration of the bob will be very high in that case. Because in the first case, displacement of the bob was high. So when the displacement of the bob increased in first case, the corresponding value of the acceleration also increased. Now, in the second case, we are taking a very near point, extreme position P as a very near point from the equilibrium position. In this case, the value of the displacement is very small. So here in the second, if we take a near point extreme position P from the equilibrium position O, if we release the force from the extreme position P, the bob will oscillate slowly. In the second case, as the value of this displacement decreased, then the corresponding acceleration of the bob will accelerate very slowly. So in the second case, the value of the displacement was very small. So the corresponding acceleration also became slow. Or the value, as in the second case, as the value of the displacement decreased, the corresponding value of acceleration also decreased. So also here the direction of the displacement is always acting towards the mean position. Direction of displacement is always acting away from the mean position. But the corresponding acceleration is always acting towards the mean position. Corresponding acceleration of the bob is always acting towards the mean position. So here the value of the displacement and the corresponding acceleration, corresponding direction of the displacement, both are in opposite direction. Direction of the displacement is always acting towards the mean position and the corresponding displacement is acting towards the, direction of the displacement is acting away from the mean position and displacement of the bob is acting away from the mean position and the corresponding acceleration is acting towards the mean position. So the first property of simple harmonic motion is completely obeyed by the process called oscillation. So the first property of the simple harmonic motion is completely obeyed by the process called oscillation. What is second property? Second property is the string. This string of length L is always imparting a restoring force on this bob of mass M. The string will always imparting a restoring force to this oscillating bob of mass M. So what is the function of a restoring force? In a restoring force, we will study restoring force in case of elastic materials. When we take an elastic material of particular shape, by applying external force, if we deform that elastic material from its original position, a restoring force will form inside the material in order to oppose the external force or in order to oppose the amount of deformation formed on that elastic material. A restoring force will form inside that elastic material, and this restoring force will always try to oppose the amount of deformation formed in the material, or the restoring force always tries to oppose the external force. So the restored by Hooke's law. Hooke's law is the famous law of the elastic material in case of elasticity in elastic materials. Hooke's law states that the restoring force directly proportional to amount of deformation x. So the restoring force Fs directly proportional to minus x, or restoring force Fs is equal to minus kx. This is the Hooke's law. So Hooke's law states that the restoring force is directly proportional to amount of deformation, but always try to oppose the amount of deformation. So here a minus sign is because this restoring force is always trying to oppose the amount of deformation x. Likewise here also, when we by applying external force, when we take the bob from the equilibrium position to one extreme position q with a displacement x, the string will always impart a restoring force on this bob of mass here, and that restoring force will always tries to make the bob from the extreme position to equilibrium position, or that restoring force is always trying to oppose this amount of displacement, or that restoring force forming inside the bob is always trying to oppose this external force or the amount of displacement x, or the restoring force forming inside the bob is always trying to oppose this amount of displacement or the amount of external force and trying to make this bob from its extreme position to equilibrium position. So because of that, even the bob reaches the extreme position also, the bob is coming back to the equilibrium position. This is because of the restoring force continuously given by the string to this bob of mass here, because that restoring force forming inside the bob is trying to make the bob from the extreme position to equilibrium position. So that's why even in the extreme position, even the bob reaches the extreme position also, bob will not stay in the extreme position. Bob is coming back to the equilibrium position O. This is because of the restoring force continuously acting on this bob of mass here. And this restoring force is imparted by the string on this bob of mass here. So this is a second property. So second property is also completely obeying this process called oscillation. Third property is this oscillating bob is always affected by property called inertia. Inertia is the property of a body in order to oppose the change of state. That is, if a body is continuing state of rest, it has a tendency to continue in its state of rest. If a body is in motion, state of motion, that body has a tendency to continue the state of motion. So here also, the bob initially the bob was in state of rest. If before applying external force on the bob was in state of rest. So after so much of oscillations also, the bob is coming back to the state of rest. That means this bob is following the property called, holding the property called inertia. So even after so much of oscillations also, this bob has a tendency to attain its initial condition called state of rest. So these are the three important properties of a simple harmonic motion, and from this example we could find that three important properties of simple harmonic motion is completely obeying the process called oscillation. So we can say that essence of oscillation as simple harmonic motion. Essence of oscillation as simple harmonic motion. So these are the basic properties, basic concepts about oscillation. Thank you.